Hi there. For this video, we'll be talking about the laws of radicals. So let's write that one down. Laws of radicals. So basically, these laws are useful in dealing with radicals, especially in simplifying it or performing operations on it. So let's go on with the first law. So the first law of radicals states that if we have the nth root of x and we raise this one to n, the outcome is simply x. To prove this, we will apply the laws of exponents. So let's have this one. Proof. First, the nth root of x raised to n can be written as x raised to 1 over n raised to n. This by definition of radicals, or how we defined it in the previous video. Then from here, we apply laws of exponents, which is the power of a power. I think that's what it's called, wherein we multiply this two. So we'll have here x raised to 1 over n times n. And we know that in multiplying fractions, we just cancel this one out. So we will have x raised to 1, or since this is an identity exponent, this one is simply x. So we have come up with the first law. This one to this one. As an example, let's have the 100th root of 100 raised to 100. Now for this one, if we try to simplify this, it will take us forever to do that. But since we have the same index here and the exponent here, we can simply just cancel that one out, and this will become 100. So that is how the first law of radical works. Let's now proceed on the second law. The second law of radicals states that if we have the nth root of xy, this one is equal to the nth root of x times the nth root of y. So we can split it up. As a proof, first we have nth root of xy. By definition, this one is equal to xy raised to 1 over n. Oops. The 1 over n should be outside the parentheses. Then from here, by laws of exponents, this one is equal to x raised to 1 over n times y raised to 1 over n. I think this one is by the power of a product law. So basically, we distributed this to this one and this one. And by definition again, this one is equal to the nth root of x times the nth root of y. So we have arrived with what we want. To illustrate this, let's have this example. Let's have the square root of 900. If we don't know this one, if we don't know the square root of 900 immediately, we can first observe that we can actually write 900 as 9 times 100. And we can actually write 100 as 25 times 4. So we will have here square root, like that, of 9 times 25 times 4. By the second law, we know that this one is equal to square root of 9 times square root of 25 times square root of 4. Now this one is easier now, since we know that the square root of 9 is simply 3. The square root of 25 is simply 5. And the square root of 4 is simply 2. So simplifying this or multiplying them up, the outcome is 3 times 5 is 15. 15 times 2 is 30. So we have come up with the answer. So this second law is really helpful, especially in dealing with large radicands. Let's have the third law. The third law states that if we have the nth root of x over y, this one is equal to the nth root of x over the nth root of y. So this is like the power of a quotient in laws of exponents. So we prove this. First, nth root of x over y. By definition, this one is equal to x over y raised to 1 over n. Then we apply the power of a quotient law. So we distribute this one to the numerator and the denominator. We'll obtain x raised to 1 over n over y raised to 1 over n. By definition again, for radicals, this one is equal to the nth root of x over the nth root of y. And we have come up with what we want. Let's have an example. Let's have the square root of 0.04. Now, it might seem tricky at first, since we're dealing now with decimals, but note that 0.04 can be written as first 0.04 over 1. Then we know that by converting decimals to fraction, what we do is we first add a decimal point here, then we move this one twice to make the numerator a whole number, then move this twice as well. So this one is equal to 4 over 100. So this one will be equal to the square root of 4 over 100. Now for this one, by the third law, we know that this one is equal to square root of 4 over square root of 100. Now, we know that square root of 4 is simply 2. And for square root of 100, if you're unsure, you can still write this one as square root of 25 times 4. Then apply the product, the second law a while ago. So this one is square root of 25 times square root of 4, or simply 5 times 2, or And this one out here is now the answer for this. Or you can actually simplify it. So 2 over 10 is equal to 1 over 5. So that is how we apply the third law. Let's go on with the fourth law, and this one is the last law. So let's write fourth law. So the fourth law states that if we have nth root of x, and this one we have another root, this time nth root of x, this one is simply equal to the m times nth root of x. So this one will be very useful. So to prove this, first we write the mth root of the nth root of x. By definition, this one is equal to, first, the outer will have nth root of x raised to 1 over m. Then in the inner one, this one by definition again, this one is equal to x raised to 1 over n raised to 1 over n. Now this one simply power of a power law in laws of exponents. So we multiply this two. So we'll have x raised to 1 over n times 1 over m. By multiplying fractions, we know that this one out here simply simplifies to 1 over nm or 1 over mm. So this one becomes x raised to 1 over mn, and going back to the definition of radicals, this one is equal to the mn root of x. So we have arrived with what we want. And now let's deal with this example. Let's have the square root, it's right here, example. Let's have the square root of the cube root of a raised to 6 and b raised to 6. Applying the fourth law, since we know that if there is no index out here, this simply implies that this one is 2. So we know that this one is equal to 2 times 3, the radical sign, and a raised to 6, b raised to 6. 2 times 3 is simply equal to 6. Now from here, we can apply the second law. So this one will be equal to the 6th root of a raised to 6 times the 6th root of b raised to 6. Then we can apply now the first law, since we have same index and exponent out here. So these will just cancel out, and we'll obtain a times b for ab. And that is the answer for this problem. So those are the laws of radicals. So just to summarize, first we have the first law. And the first law states that if we have the nth root of square root of x and we raise it to n, this one is equal to x. The second law states that if we have the nth root of xy, this one can be written as the nth root of x times the nth root of y. And the third law, if we have the nth root of x over y, this one is equal to the nth root of x over the nth root of y. And lastly, the fourth law, if we have the mth root of the nth root of x, this one is equal to the m times nth root of x. So these are the 4 laws of radicals. As an exercise, you can work on these 2 examples. First is if we have the square root of 16 over 81. What is the answer? And the second one is if we have the 4th root of a b squared c raised to 4. So try to apply the laws of radicals in these exercises. So that's it for this video. Feel free to comment down below your answers and your solutions to these exercises. And if you have any comments and recommendations regarding the whole lesson, please don't hesitate to comment it as well down below. So that's it, and that is all for this video.